So welcome to Earth Systems 3209, Unit 1. And Unit 1 is basically just an introduction to Earth science. Topic 1 in this course is Earth systems as a science. And it's totally obvious that Earth science is different from all other sciences, in that with Earth science, the first thing you have to do is to have a global perspective. So you need to be able to really see things on a really large scale. And a lot of times things are connected to each other on that large scale. So, for example, it's not like chemistry where you just watch a chemical reaction take place inside of a test tube. You may possibly be looking at the formation of a large mountain chain, which could be best looked at maybe from space, where you're actually looking at the movement of plates on a very, very global, large-scale perspective. The other way that Earth science differs from other sciences is that I think you need to be really good at all of the sciences in order to be a really good Earth scientist. And that's why we sometimes refer to Earth science as being a combination science, since it draws on areas such as physics and chemistry, biology, astronomy, meteorology, etc. The other really big thing about Earth science is that you need to be able to think in a different way. In terms of time, you need to be able to think in geological time, which is really different from thinking in human time. As an example of global perspective, as you can see in the diagram here, the formation of the Himalaya Mountains, which basically formed from a collision of India with the Eurasia Plate. And, this basically took place over the course of 100 million years. And as you can see in the diagram in the right, that basically you can see that India was moving this way and over geological time collided into Eurasia. We would think of 100 million years as being a really, really, really long time in human time, but in terms of geological time, it's actually not that long at all. Earth scientists are experts in many sciences, so if I look at myself and in terms of the education that I did, in order to be an earth scientist, I had to do physics, I had to do biology, I had to do chemistry, I had to do earth science. So there's a lot of different types of sciences that I guess are combined, and you're always pulling from those sciences every single time that you're doing earth science. Why do you think that earth science is important in everyday life? Well, that's obvious if you consider things like volcanoes that happen relatively frequently, depending on where you live in the world. And typically wherever there's volcanoes, there's also earthquakes. We hear of things like mudslides. We hear of things like extreme weather. And so there's a lot of things that, if you were to watch the news or any type of media for that matter, you'll realize that earth science is very important in everyday life, even astronomy as well. Geological time is crazy to think about, and you have to consider that Earth is 4.54 billion years old, and we're talking billions of years here, which is really, really hard to get your head around. Naturally, the Earth formed 4.54 billion years ago, and humans are believed, to have existed for the last 11,000 years. So there's quite a lot of time that's there since the Earth actually formed. And so, if you were to consider, the extinction of dinosaurs, and dinosaurs are believed to have happened roughly about right here at the end of the Mesozoic era and the beginning of the Cenozoic era. As you can see from this diagram, 65 to 66 million years ago is not that long ago, but we think of the dinosaurs as being really, 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 really far back. Just some probing questions just to kind of get you thinking about earth science if you haven't done the course before. And, for a lot of people, other than Science 1206, there are no prerequisite courses for this course. So for some people, this may be the first time. So I'll ask you some things like, if I had several rock layers, how would you determine which one is the oldest rock layer? And that would totally apply to sedimentary rocks. The answer to that question is that the layer on the bottom would be the oldest. How can I determine whether a particular mountain peak owes its shape to folding, faulting, glaciation, or volcanism? Well, that's certainly a question that would take much longer to answer, because some volcanoes, some mountains are volcanoes, some mountains are formed by glaciers, some mountains are formed by a process called faulting, and similarly a process called folding. How can I identify certain rock samples? Well, naturally, as a geologist, a person who studies rocks, you have to be able to pick up a rock sample and you have to be able to name it. Someone could show you a rock and ask you to identify it, and you would also have to be able to do that, knowing that there's 3 different types of rocks: sedimentary, igneous, and metamorphic. How can I determine the thickness of Earth's crust? Well, we live on Earth, and nobody's ever been down inside of the Earth. And even when you consider wells that are drilled for oil, you think that those wells are being really, drilled really far down. The truth is they're not. So how do we know about the fact that Earth has different layers? And the answer to that question is because of earthquakes. So everybody thinks of earthquakes as being, very destructive and negative. Well, earthquakes actually play a really good cause, in the sense that they produce waves that we can use to study Earth's interior. How can I determine the general look of Earth at a particular time during its history? That's a little tough. Typically what we do is we look at things that are taking place on Earth today, and that provides insight into how things looked on Earth at particular times in history. How can I determine the origin of Earth's atmosphere and hydrosphere? Well, simple answer to that question, that we would not have an atmosphere or an hydrosphere if it wasn't for volcanoes. How do we know this? Well, naturally, we know that the Earth has layers on the inside. So if you were looking at, the fact that the Earth has a core, which is an inner core and an outer core, and above that we have a mantle. That mantle can even be broken down a little further, because towards the top of the mantle we have a section called the asthenosphere, and above that we have a section called the lithosphere, and the lithosphere is made up of crust, and the crust is what is broken up into little tiny pieces or slabs, which we call plates. And hopefully everybody in this course actually heard of the theory of plate tectonics. It's a very, very important theory, and it explains a lot about different Earth processes. So when we look at Earth science, basically it comes down to major branches and minor branches, and there really is only 4 major branches, whereas with minor branches there's actually quite a few. So the 4 major branches of Earth science is geology, and geology is all about examining Earth, how Earth formed, what is Earth made of, how is Earth changed over time, and how are those changes still proceeding. Meteorology is more to do with the atmosphere and different conditions of the atmosphere, and typically we think of meteorology as being the study of weather and less climate. Climatology would be the study of climate. So, when you think of meteorology as typically, weather on over the course of a very small number of days. Astronomy is also a major branch of Earth science. It would be all about the universe, and we know that we are just one solar system inside a very big universe that existed well before our solar system even formed. And so we hear of things like planets and stars and comets and asteroids and all those things. So they're all things that you would study if you were to become an astronomer. The 4th major branch of Earth science would be oceanography, and essentially anything associated with the oceans would fall under this branch of Earth science. It could be variations in the salt content, which is salinity of the water, variations in temperature of the water, depth of the water, different landforms and features that you would get on the bottom of the oceans, ocean currents, that kind of thing. On a public exam, they may just say which is a major branch of Earth science. They could have 3 minor branches of Earth science and 1 major branch, or they could just come out and say, which is the scientific study of the atmosphere and conditions of the atmosphere on a daily basis. And naturally, the answer would be meteorology. In terms of minor branches of Earth science, there's quite a few. And so, ones that I typically talk about in class that are kind of fair game for inclusion on the public exam would be crystallography, which basically studies the crystals and the shapes of crystals, which make up minerals. And when you study crystallography, you're actually looking at minerals at an atomic level. Then there's geochemistry, and geo means earth, so basically anything that involves chemistry of the earth. Likewise, geophysics, anything that involves physics of the earth, sometimes using physics to better understand earth. Geomorphology would have more to do with studying the earth from a morphology standpoint, which means shape. So if you combine those two meanings, it would be the study of landforms. Hydrology would be the study of water, so that would include, water in the atmosphere. It would also include water on Earth's surface, and it would also certainly include water in the subsurface that actually flows through the ground. Mineralogy is the study of minerals, and we know that there are over 4,000 different minerals, so the study of mineralogy is quite massive in itself. Paleontology would be the study of fossils, and so it could be actual remains of once living things, or it could be traces of things that were once alive, like footprints or trackways. Petrology is not the study of petrol, is not the study of oil, it's actually the study of rocks. And I guess that's where the meaning comes from, petroleum, in the sense that petroleum comes from rocks. So if you're a petrologist, you are a person who would study rocks. Seismology would be the study of earthquakes and waves that are actually produced from earthquakes, which we call seismic waves. Stratigraphy would relate to sedimentary rocks, and it would mostly relate to rocks that are deposited in a layer. The study is actually called after William Strata Smith, and that's where the word strata comes from, which actually means layers. Volcanology would be the study of volcanoes and everything relating to volcanoes, a very fascinating field, considering things like lava tubes, magma, really, really, really high temperature fluids for sure. How is earth science related to other scientific fields? Well, as we said before, it's all interconnected. So if I were to pick some examples, and if you were an oceanographer who's studying things on the ocean floor, well then naturally you would have to know some geology or rely on a geologist. For example, if you wanted to study the rocks on the ocean floor. If you're a biologist, which is somebody who studies life forms, naturally there's a link to paleontology, who studies fossils. And so fossils help us with understanding things like the evolution of life, but it's hard to understand fossils if you don't understand anything about biology. Likewise, if you were looking at the San Andreas Fault, which we're looking at over here, which is a transform strike-slip fault that actually runs through the state of California in the United States. It's actually a magnificent feature, actually can be seen from space. Geologists study that fault on a daily basis, and a lot of times people ask the question of when is there going to be movement along the San Andreas in the future, thereby causing an earthquake. And naturally, you would have to rely on physicists and geophysicists who could actually, study such things as force and strain to see, if the rocks are really close to actually breaking and releasing a massive amount of energy. If you're a mineralogist studying minerals, then naturally you would have to know chemistry, because minerals are compounds which are made of elements, and elements are made of atoms. So essentially, mineralogy all comes back to chemistry. And that is topic number 1.